So a few weeks ago, I was at a restaurant, and it was an Italian restaurant, and I couldn't decide whether I wanted spaghetti or if I wanted some lasagna. And when the waiter came over, I was still flustered. And so I said, I'll take a slice of spaghetti. The waiter was very confused because a slice of spaghetti doesn't really make sense. And in this moment, I realized something really interesting. These types of foods have a unique structure to them. We can see in lasagna, we have this nice layered structure, whereas in spaghetti, it's much more disorganized. And I realized that the structure of these materials, that is the way that the ingredients are organized, is playing an important role in their properties. For example, whether we slice it or whether we use a fork. And so this concept doesn't just apply to food, it also applies to chemistry and material science. So I was really excited to figure out how I could take this and put it into my own research. And as it turns out, the layered materials that I work with have a structure that look just like lasagna, right? And I thought, this is such a cool idea. We have these sheets of atoms that are stacked on top of each other, and they're separated by these molecular sauces in the same way that lasagna is. And what I wanted to do was figure out how we could use these materials in order to improve a variety of different applications. And these materials, they're used in things such as batteries, they're used in construction to make them stronger, they're also used in cars to make them lighter, improving efficiencies, and we also use them in drug delivery, and we can use them to purify water. All of these technologies are important for a world that we want to make more sustainable. The cool thing about layered materials is that they are everywhere. And if I can get a quick show of hands, who here has used a pencil in the last week? Yes, everyone, right? Doing your crossword puzzles, of course. Well, the cool thing about pencils is that they are layered materials, at least the graphite is, right here at the tip. So if we zoom in on this, essentially we have this layered structure all stacked together, but the sheets can slide past each other. And when they do this, and we rub it on a sheet of paper, what happens is that the layers come across and they form a pencil mark. This wouldn't be possible if it wasn't for the layers structure. So the structure is critically important to the properties of the material. In this case, our ability to write. Now, in my graduate work, I was super interested with this idea of how structure is affecting the properties. And what I wanted to figure out is, if we started breaking these structures down, what would happen to their properties? So to provide some context for this, one of the experiments we started off with was looking at how, if we just took this material and we put it into water, what would happen? And essentially nothing. It's pretty boring. It doesn't mix. But if we take this material and we spread it apart, separate it, what happens is we can now get it into the water. And this is really cool. We get this beautiful pink translucent solution. And so in the solution, we realized that we were changing the properties. We were now able to get it to mix. And so I was really, really motivated by this idea. And I said, how can we take this further? How can we explore this in a more exciting way? And so we took this material and we added something new to the structure. In this case, I wanted to take the structure, starting from that lasagna shape, and begin crushing it down in a way that it forms a new type of structure. And so the idea was to add this connector piece that would take everything together. So kind of going from a confetti shape to more if you balled up all of that confetti. And so we got a structure that kind of looked like this. And when we put it into water, of course, it no longer was able to go into the water, highlighting this, again, idea that because it wasn't mixing, we were changing the properties. So the structure was having an important influence on our properties. So this material is really cool because it's actually a brand new kind of material here. It's never been made before, and we're really excited about that. And we're also excited for the opportunities that it presents us. So one of them being energy storage, and the other being water purification. What we're hoping for is that as we explore these materials more, we can use these type of applications in order to make our world a more sustainable place. So the next time that you're ordering lasagna or you're having spaghetti, I hope that you guys all will remember the importance of how property is influencing structure, and will be reminded of how not just our foods, but also the materials that are all around us are playing an important impact in making the world a more sustainable place. Thank you.